Static methods and fields. The static keyword defines a static method or field for a class. Static properties, fields and methods are defined on the class itself instead of each instance. Static methods are often used to create utility functions for an application, whereas static fields are useful for caches, fixed configuration, or any other data you don't need to be replicated across instances. Here we have an example. We have the class name point inside of the curly braces. We have the constructor with parameters x and y, and inside of the curly braces of the constructor we're gonna use the keyword this, and we're gonna chain it to the parameters. So we have the keyword this that x is assigned to the parameter x. We end up this statement with a semicolon, and now we have the keyword this that y, and we assign it to the y parameter. We close the curly braces of the constructor, and now we're gonna use the keyword static, and we're gonna display name. So we have static display name, and we're gonna assign it to this string point. We ended up with a semicolon, and now we're gonna use again the word static, and we use the function distance, and we're gonna have two parameters a and b. Inside of its curly braces we're gonna have a constant declaration dx that is gonna be assigned to the parameter a dot x minus the parameter b dot x. So we end up with a semicolon, and now we have the constant declaration dy that is assigned to the difference of the parameter a dot y and the parameter b dot y. So we end up with a semicolon, and now we're gonna return math dot hypath, and we're gonna return the dx and dy, and these are methods, these are mathematical equations, but pretty much what we are gonna return here is gonna be the square root of dx raised to the second power plus dy raised to the second power. So we close the curly braces of the function distance, and we close the curly braces of the class point. And here we have this we have the constant declaration p1, and we're gonna assign it to the new point. So remember, here we have the class and the class's point. So here we are assigning p1 to new point with parameters 5 and 5. So we end up with a semicolon, and we're gonna do the same with the constant p2, and we're gonna assign it to the new point with parameters 10 and 10. So when we have p1 that display name, we're gonna get undefined. When we have p1 that distance, we're gonna get undefined. p2 display name undefined, and p2 that distance, we're gonna get undefined. And we're gonna see this in the Chrome developer tools, but first I want to explain it. So now we're gonna cancel that log point that display name. So we want to cancel that log point that display name. So the result that we're gonna get is gonna be the string point. And then we're gonna cancel that log point that the function distance with parameters, but the parameters are gonna be p1 and p2. And the result that we are gonna get is gonna be the number 7.07. And we can check it out here in the Chrome developer tools. We go to any tab and press Ctrl Shift I. So we paste it with Ctrl V, press enter, and there you have it. When we cancel that log point that display name, we're gonna get point, since the display name is assigned to the string point. But when we cancel that log point that distance, so the distance is, here is the function distance, and what we are gonna return is gonna be this math.hypath dx comma dy. And again, what it returns is gonna be the square root of dx raised to the second power plus dy raised to the second power. So I want to show you something here. If I can just I don't know, can go to this tab we have the math.hypoth. The math.hypoth static method returns the square root of the sum of squares of its arguments, that is. So you have this equation. But for example, like if you have here in this example, we have cancel.log, math.hypoth, and we have the parameters 3 and 4. The result that we are gonna get is 5. Why? Because we're gonna get the square root of 3 to the second power, that is 9, plus 4 to the second power, that is 16. So we're gonna have the square root of 9 plus 16, that is the square root of 25, and the result is gonna be 5. So that is what's happening with this return, and this is pretty much is in the references math.hypoth. But here in this case, as a parameters, we have p1 and p2. So in this static distance, we have as properties a and b, and the math.hypoth that we are gonna get as parameter is gonna be dx and dy. So in this case, we're gonna have 5 minus 10, that is gonna be minus 5. That is gonna be our dx minus 5, and then we're gonna have dy, that is a.y minus b.y. So we're gonna have 10 minus 5, that is gonna be 5. So we're gonna have minus 5 raised to the second power plus 5 raised to the second power. So that minus 5 is in parentheses when it's raised to the second power. When it's raised to the second power, it's gonna be a positive 25. And then we have positive 5. When we raise it to the second power, we're gonna have 25. So it's gonna be 25 plus 25. The result is gonna be the square root of 50. So, and the square root of 50 is gonna be 7.07, and all this whole number. This is the result that we're having here. So that is that. Field declarations. With the class field declaration syntax, the constructor example can be written as, so here we have the class rectangle. Inside of the curly braces we have the height, and we initialize it to 0. We ended up with a semicolon, and then we have width. We don't initialize it, but we end up with a semicolon. After that, we have the constructor with its parameters height and width. Inside of the curly braces, we're going to use the keyword this. This that height is going to be assigned to height, and this that width is going to be assigned to width, the width parameter and the height parameter. So that is how we can do it here. Class fields are similar to object properties, not variables, so we don't use keywords such as counts to declare them. In JavaScript, private fields use a special identifier syntax, so modifier keywords like public and private should not be used either. As seen above, the fields can be declared with or without a default value. Fields without default values default to undefined. By declaring fields up front, class definitions become more self-documenting, and the fields are always present, which help with optimizations. So see public class fields for more information. So you have this link if you want to read more. You have this article here. And then we have private class features. Using private fields, the definition can be refined as below. So we have the class rectangle inside of the curly braces. This time we're gonna use the number sign, the hash or number sign, height, and we're gonna initialize it to 0. We end up with semicolon. Then again we have the number sign width. We end up with a semicolon. And now we use the constructor with parameters height and width. Inside of its curly braces, we're gonna use the keyword this that number sign height, and we are gonna assign it to the height parameter. We end up with a semicolon. We use the keyword this that number sign width, and we're gonna assign it to the width parameter. So we close the curly braces of the constructor, and we close the curly braces of the class rectangle. It's an error to reference private fields from outside of class. They can only be read or written within the class body. By defining things that are not visible outside the class, you ensure that your class's users cannot depend on internals, which may change from version to version. Private fields can only be declared upfront in a field declaration. They cannot be created later through assigning to them the way that normal properties can. So for more information, you can see the private class feature. So you have this article here.